This is the Chapter 11 quiz, Chemistry 101, Spring 2021 video, number 1 of Chapter 11 quiz. Of these formulas, which is the formula of an alkyne? The general molecular formula for an alkyne, CnH2n minus 2. So of these, if we look at where the value for n equals 10. So is C10 H2 times 10 minus 2. So this is C10 H. Is C10 H18 matched by this? No, this is C10 H20. Though, so this is not an alkyne. Because the combination of n being 10, this is 18, but not 10. Let's look at the C8 species. If it is C8, it is C8 H2 times 8 minus 2. C8 H2 is 16, 14. Is this the formula based on a C8 count for this compound? No, it's not. Let's look at the formula for the C9. So C9 H2 times 9 minus 2. C9 H2 times 9 is 18 minus 2 is 16. Is this match that? No, this is not an alkyne. C10 H2 times 10 minus 2. C10 H20 minus 2 is 18. So does C10 H18 match this? Yes. So of all these formulas, A is the formula for an alkyne. Number 2, the compound below is classified as what type of compound? What kind of bonds between our carbons do we have? Do we have all single carbon carbons? Do we have double bonds, or do we have a triple bond? Single, 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 double, single, single. So this is a double bond. This is an alkene, the ENE. Number 3, are the two compounds shown below, are they cis-trans isomers, constitutional isomers, or are they non-isomers of one another? A couple of things we have to understand. Isomers, compounds that have the same molecular formula, but differing connectivity between the two. So what's the molecular formula here? C2H6O. What's the molecular formula here? C2, 1, 2, 3, 4, 5, 6, H6O. Do these two have the same molecular formulas? Yes. Do they have differing connectivity amongst all the atoms present? Yes, they do. So they fit the best definition of a constitutional isomer. There are no double bonds present in either of these molecules for these to be cis-trans isomer to one another. These are constitutional isomers. Let me shrink this down a bit so we can get everything on the same page. Of these, which does not have the property of cis-trans isomerism? Again, we're looking at what is present on the double bonds. If these are different from one another, and these are different from one another, this can have a cis-trans isomer. Again, is this different than this? Yes. Is this different from this? Yes. This is a cis-trans isomer of that. What about this guy? Is this guy different than that? Yes. Is this guy different from this guy? Yes. This can have cis-trans isomerism. Are these two different from one another? No, they are not. They are identical to one another. Then this is not, it does not have the possibility for this to have cis-trans isomers. So this is neither a cis isomer nor a trans isomer. Number 5, what kind of reaction is shown to you below? This is the addition of Cl2 or Br2. When you end up adding a dihalide, 2 chlorines or 2 bromines across the double bond, you produce the dihalide. So this is, since we're adding halogens, this is halogenation. Answer B. Number 6, what is the name or general type of reaction shown below? We have monomers. We have ethylene monomers. We have 3 monomeric units. Reaction happens. All these monomeric units are linked together to create a polymer. So this is a polymerization reaction. 3 monomeric units joined together form a polymer. Poly meaning many, mer meaning units. Many units, many mers, polymer. Which monomer unit is used to synthesize the following polymer? Where do we see in this system repeating structures? If we look here at this end, where do we see another oxygen that's involved in a single bond? Right there. So here and here are where the monomer units are defined. This oxygen right there, C, double bond O, down, up, O, H, up, up, O. So basically, divide there between the oxygen and C double bond O, divide there between that oxygen and that C double bond O, divide there between that oxygen and that C double bond O. We have 1, 2, 3 carbons. At this third carbon, we have an OH. One, 2 carbons away from that OH, we have a C double bond O. 1, 2 carbons from the OH, we have a C double bond O. But we need 3 carbons. 1, 2, 3 carbons. Here we only have 1, 2. Here we have 1, 2, 3, but there's no OH there. Here there is no OH that's not attached to the C double bond O. So it's not this guy, it's not this guy. We're looking here, we have 1, 2, 3, 1, 2. It's not this guy, 1, 2, 3. This then is bonded to another C double bond O. The answer here is B. Number 8. Of these compounds, which is a tri-substituted aromatic? Again, the aromatics are those 6-membered ring systems that have the alternating single and double bonds. Tri means 3. Substituents, pieces of spinach. So which of these 4 compounds only has 3 things hanging off the aromatic ring? Well, there's 2 there, there's 1 there, there's 1, 2, 3, 4 things there. 1, 2, 3. So 8 is C. Number 9, what is the IUPAC name for the following alkene? We are looking for that longest continuous carbon chain that numbers sequentially through both carbons. So we can't go 1, 2, 3, 4, 5. We can't go this way or this way because that doesn't count both carbons of the double bond. It does not count through the double bond, both carbons. We can't go 1, 2, 3, 4, 5 because that only counts this carbon of the double bond. It doesn't count that one. Remember, both carbons, and the numbering has to go through both carbons sequentially. So let's say 1, 2, 3, 4, 5, 6, 7, or 6, 7. Either way, it's symmetric. So let's go 6, 7 like that. Second thing, 7 carbons is a hept. H-E-P-T. It's a hept. Let's do that down here. H-E-P-T. It's a hept. 7 carbons. We have a double bond present. The wording that we use to indicate a double bond is an ene, E-N-E, a heptene. Where in our 7 carbon sequence does that double bond occur? Now we're saying, do we number 1 and go to the right, or do we go 1 and to the left? Either way we choose, whichever way we choose, the double bond carbons have to be where the first carbon has the lowest numbering in the sequence possible. So if we number from left to right going this way, the double bond is at C4. So left to right, C4. We go from right, starting this end, to left. It is 1, 2, 3. Right to left, the first carbon of the double bond is at C3, which is a lower numbering sequence, 3. So this is a hept, a 3-heptene. 7 carbons with the first carbon of a double bond at the 3 position. So we've taken care of just about everything except 1, 2, 3, 4, 5, 6, 7. We got that guy right there and this 2 carbon fragment at C3. Again, what do we have at C3? We've got a 2 carbon fragment. 2 carbon fragment is F. F means 2 carbons. Since it's a piece of spinach, it's a substituent. It's hanging off our main chain. We add the YL. It's at the 3 position. We've got a single carbon fragment, a meth, single carbon fragment at C4. We list these alphabetically. So E comes before M. So 3-ethyl, 4-methyl, 3-heptene, number D. Number 10, what's the IUPAC name for the following alkane? Again, we have a multiple bond. Therefore, the carbon chain sequence numbering has to occur sequentially through both carbons of the triple bond. So both carbons of the triple bond are right there. So it is, let me see if I can get that out of the glare. We'll move it down a bit. There. Both carbons are out of the glare. Sorry, these 2 carbons, carbon-carbon triple bond. This makes it a Y-Ne. So we need to count the number of carbons that goes through both carbons that are part of the triple bond that has the longest continuous connection of carbons. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, no. 1, 2, 3, 4, 5, 6. So the longest continuous carbon chain that connects both of the carbon-carbon triple bonds sequentially is 6. That makes it a hexyne. Then you need to tell me where in the series of 6 carbons is the first carbon of the triple bond. So this means either numbering left to right or right to left. Well, I think you can see we need to number from left to right. If we number from left to right, the first carbon of the triple bond is at the 2. If we start here as 1, 1, 2, 3, 4. 2 is lower than 4, so we number, this is C1, that is C2. So it is a 2-hex ion. Do we have any other piece of spinach hanging off our 6 carbons? Yeah, we've got a bromine, so that's a bromo. So we know where it is. What is it? It's at C5. 5-bromo. What is this? It is a single carbon fragment. We're taking care of that. A single carbon fragment. What is it? Meth. Since it's a kit single carbon fragment, methyl. Where is it? 5. So we have 5-bromo, 5-methyl, 2-hexyne. Hopefully this has cleared up questions that you might have about the Chapter 11 quiz. If you have any problems, please make an appointment to come to me during my office hours and we can talk about this so I can get your questions answered. Thank you very much. Bye-bye.